Hello everybody, welcome back to Channel ANZ Machinery. Chile is a company of Indumotora that specializes in the manufacture and marketing of suspension and transmission products for the mining, railway, industrial and agricultural industries. It was founded in 1967 under the name Rockwell Standard Automotive Components, with the purpose of complementing the automotive industry of the time by supplying parts and components to clients such as Ford Motors. Among its offerings were engines with spiral springs for their automotive line, addressing a pressing market need. In 1970, CART Chile expanded its product line to serve the mining and railway industries, maintaining the same production, quality, and safety standards as its automotive line. The steels used for manufacturing traction and compression spiral springs for large-scale mining and railway applications are SAE 6150H steels. These steels are composed of carbon, manganese, chromium, silicon, and vanadium, the latter of which inhibits grain growth at high temperatures, improving the resistance and toughness of the spring while achieving high elasticity, making it an optimal material for spring manufacturing. Manufacturing process of a spring. The manufacturing process of a spring begins with cutting steel to the desired diameter and length. Once cut, the steel bar is straightened to ensure it is completely even. Depending on the spring's specifications, the bar undergoes a grinding process to eliminate surface defects and ensure it is free from cracks or imperfections that could cause issues during tempering. After grinding, the ends of the bar are rolled to form the spring's seat or base. This involves heating the bar to 900 degrees Celsius and rolling it in a machine with elliptical rollers to generate the conical shape at its ends. The next step is the winding of the spring, which starts with controlled heating of the bar. The bar is heated evenly to ensure uniform austenitization, a transformation at 900 degrees Celsius where perlite is converted into austenite. Once this is achieved, the bar is wound into a spiral shape using machines equipped with molds to ensure dimensional consistency across all springs. After winding, the red-hot spring undergoes tempering, where it is rapidly cooled in an oil tank. This critical step ensures the transformation of the spring's structure, a key factor in achieving the desired quality. Tempering results in extremely hard springs. To achieve optimal hardness and toughness, the spring is reheated to a temperature between 390 and 460 degrees Celsius for at least 60 minutes in a controlled atmosphere. This process, known as tempering, reduces internal tensions in the steel, enhancing its durability and flexibility. Final steps in spring production. The spring's seating faces are then ground flat to ensure proper alignment during assembly. A process known as shot peening follows, where small 2mm steel spheres are fired at high speed against the spring. Proper shot peening extends the lifespan of the spring by 3 to 4 times compared to untreated springs. Subsequent testing ensures the springs meet standards for load, rigidity, and flexibility. Springs are compressed from their free position to their solid position to eliminate residual stresses and ensure the spring retains its original height and elasticity. Finally, the springs are coated with electrostatic paint, forming a protective film that resists salt mist and prevents oxidation, making them suitable for humid and contaminated environments. Market leadership and clientele. CART Chile, part of the Indumotora Group, has established itself as a reliable provider of high-quality springs. Its expertise and experience in product development and commercialization have earned the trust of major companies in the mining sector, such as Codelco, Pacific Mining Company, and Collahuasi Mining Company, among others. In the railway sector, clients include Antofagasta Bolivia Railway, CAF Railway, and Soquimich Railway. CART Chile's dedication to innovation, quality, and customer satisfaction makes it a leading choice for springs in the industry. The WIM100HCNC is a custom-made hot spring coiling lathe from Fortuna Federn, designed for coiling compression suspension springs with wire diameters up to 100 millimeters. These machines are tailored to meet specific customer requirements, offering both automatic and semi-automatic options for hot coiling tasks. They efficiently handle tapered bars and cylindrical bars with straight cut ends, ensuring precision and reliability. Fortuna Fettern's advanced technology and customization capabilities make the WIM100HCNC an ideal choice for producing high-quality springs in demanding industrial applications. Whether for automotive, heavy machinery, or other sectors, these coilers deliver optimal performance and flexibility to suit diverse manufacturing needs. Bending large steel springs by hand. A guide to crafting 2-bar springs. Bending large steel springs by hand requires precision, patience, and a solid understanding of steel's behavior under stress. This method is particularly effective for crafting 2-bar springs, which are widely used in mechanical and industrial applications. Here's how to approach the task. Choose high carbon or spring steel for flexibility and resilience. A propane torch or forge to heat the steel to its optimal bending temperature. A sturdy base to shape the spring. A custom jig or clamps to ensure uniformity. Heat-resistant gloves, goggles, and protective clothing. Cut the steel rods to the required length. Clean the surface to remove debris or oil that may affect the heating process. Gradually heat the steel to a glowing red or orange color, around 900 to 1100 degrees Celsius, 1650 to 2000 degrees Fahrenheit. This makes the metal malleable and easier to bend. Place the heated steel on the anvil or jig and apply steady, even pressure to bend it into the desired shape. For 2-bar springs, ensure symmetry for consistent performance. Allow the steel to air-cool slowly for initial hardening. Avoid quenching at this stage to prevent brittleness. Reheat the spring to a lower temperature, 400 to 600 degrees Celsius, and cool it again to enhance flexibility and reduce internal stresses. Inspect for cracks or deformities, then polish and coat for corrosion resistance. Hand-making 2-bar springs is a rewarding process that combines skill and craftsmanship. By mastering these steps, you can create durable springs tailored to specific applications.